All right, hi everybody, and here's my slides. I hope you can see those too. So we're going to talk about the future of software development. We're going to touch a lot of aspects of life and what comes in the future, what's next for all of us as software developers, as well as just people. A lot of change coming. So a lot of slides, about 90 slides in 25 minutes, so we are going to go fast. So one of my favorite quotes about the future from William Gibson: the future is already here, it's just not evenly distributed. There's lots of labs, universities, scientific work happening behind the scenes. You don't really know what's coming next until it's suddenly available. So we're going to peel back the curtain a little bit and look at a lot of things happening now you may not be aware of, some you may be, and how it's going to fit into our lives. So quick intros. As John said, I've been in software for quite a while, CTO of Perforce, formerly RogueWave. Founded OpenLogic in the open source space, worked at some big companies, a lot of analysts predicting what's next, analyzing markets and futures, a lot of conferences, speaking internationally for 20 plus years. And of course, most importantly for predicting the future, I have the goatee to think about big picture things. All right, so things we're not going to talk a lot about, the things you're probably doing now: immutable infrastructure, microservices, or maybe you're working on those, or serverless, right? Electron, things like that. And it's a little funny to see things like JDK9 on this list from a couple years ago. I'm going to touch on a couple things in this list: deep learning, GraphQL, but a lot of it is what's beyond this stuff. So let's set some context first with hardware. Well, NVIDIA's already got a card they think is powerful enough to give us full autonomous driving capabilities. A lot of power, 300 plus trillion operations a second, over a terabyte of memory, data access, 500 watts. To put that in perspective, the fastest supercomputer in the world just 15 years ago was slower, the size of a house, and took 750,000 watts to power. And NVIDIA has cards twice as fast now, coming soon even faster. And they're just cards. You can stick a bunch of these in one machine. You don't need cities full of machines to get there. So what's the next 15 years look like if that's what we can do now? Now, for now, we still have an advantage as humans. We can store a lot of data. We have really good parallel processing and super low power usage. So for now, we're still in the lead. However, I'm not sure how long that'll last. IBM's got a brain chip, lots of other companies working on things like this to run AI much, much faster and with a lot less power than we've used in the past. So don't rest on our laurels. We'll talk more about how we keep up with the machines later. All right, so that's context for hardware. What about software? Well, we heard about 9 years ago now, software is eating the world. And what does that mean? A lot of people are still confused, I think, over that. Well, it means software companies have been turning physical devices and brick and mortar stores and things into software and bits, and are taking the profits, taking the future away from the companies who have not made the transition. Companies like Amazon used to sell books. Anybody remember those days? Now it's about doing over a third of all the e-commerce in the world through their sites, and coming soon things like drone deliveries, digital delivery of movies and books and everything else. Apple, you don't go to the mall to buy a CD anymore from a music store. You get bits. It's iTunes. You don't go to Blockbuster. You get bits from Netflix. Tesla, a company you may have heard of, they make a really cool tablet. You can surf the internet and do things, and they wrap a car around it so you can take that tablet anywhere because it is kind of big and heavy. Pretty cool. Over-the-air software updates. Again, bits, software, flexibility, adaptability. A company called Uber has software, right? That's all they've got. They've got an app worth $50+ billion at one point, where you can get a perfect stranger to drive you wherever you want by touching a few buttons on in the supercomputer in your pocket, right? Bits revolutionizing. And it's not just those kinds of companies. Analysts are saying everybody's in software, all the global 2000, right? Every company is a software company. Even companies that made physical devices in the past are switching to bits, licensing their intellectual property, and doubling the size of their development teams as they're going through digital transformation. It's so important that it's making the CEO's top 5 strategy list for success. You have to be in software, therefore you need software developers, you need bigger teams, you need to manage those teams. Ever had a can of chicken noodle soup. Even these guys have a tech fund. Everybody is in the game now. If you look at some of the things that we saw in the past, the things that are going away, the Blockbusters, the music stores, the mall, dealing with your own data centers in a lot of cases, right? Those were kind of heavy, physical, inconvenient, do it at their schedule, go to where they are. Things on the left, more about bits, software, convenience, declare what you need. They'll take care of the details. It's more of a service for you as a consumer. I think we're seeing the same thing with software. Tools and technology is somewhat on the right, where I'll tell you all the details, a little bit heavier weight, more imperative, procedural on the left, declarative, easier to access more, give it to me the way I want it, not the way you want to provide it. And if you look at some of those advanced things from a decade ago, think about life before the iPhone, smartphones, Android, before the advent of the cloud and Netflix and Uber. We've seen a lot of change in our lives in that decade. The prediction is we're going to see 10 times as much change in the decade we're right in the middle of right now. That is a massive amount of change. Part of that is being brought on by the fact that we're going to double the number of users on the internet within the next few years. And those people that are joining the internet are going to want to innovate. They want to create things. And lucky for them, it cost 0.1% as much as it did to create a startup now than it did 20 years ago when you had to buy physical machines and license software, et cetera. Now it's cloud, open source, things as a service. And if $5,000 is too much to raise, it's going to be massively easier to get funding just a few years from now than it was a few years ago. 10 times as much available from crowdfunding. Sizes of the funds are getting massive, continue to grow. So much new innovation with the new people coming on, starting new companies cheaper, faster than ever before. Analysts are saying by next year, we're going to see a 10x growth in all these apps and services, and over half of the entire global economy being digitized 1 year from now. So companies making cars and physical things now going to make money off bits, software, services online. That's driving the development of more apps than ever. It took us 40 years to get to 500 million apps in the world. How long to get to the next 500 million? Just 3 more years. We're right in the middle of it. So massive spike in the number of apps, not applications. We'll talk about the difference in a minute. That's fast. Massive pressure on developers, teams, tools, processes to do more than ever before. And that's pushing us to adopt new architectures, new technologies, things like what Gartner calls mesh app service architecture, microservices, cloud, serverless, containers, the things you're probably aware of, where small bite-sized things, whether they're user interfaces like apps or services, microservices do one thing well, that are composed into bigger wholes, as in big pieces. Veneers basically now are applications. They're just touching a bunch of services and bolting together AIs to look like a big thing. They're really small, individually moving and developed parts by different teams. That's how you get there. You do that with microservices, of course. You do that with APIs. That's really the underpinning of all these new architectures. API management, you may have heard of. It's kind of when you get to a certain scale, you want consistent things like security. I think of it like an API firewall. Consistent security across all your teams, no matter what frameworks, platforms, languages, et cetera, they're using, to automatically transform protocols and data formats. Think HTTPS and SAML and OAuth and XML and JSON, just to handle all those different things. So as an API writer, you focus just on your API, let the platform do the rest. Same thing on the internal side. To implement the API, use service mesh, things like open source, Istio, Linkerd, to again enforce consistent security, quality of service, A/B testing, deployment, blue-green, automatic rollbacks, those kind of things at the microservice level. So again, you as a microservice developer focus just on what you need to build, let the platform take care of the rest. Declare what you need, have it do the details for you. API management, external focus, security focus. There's one IT can manage, audit, control it, comply with standards, gives you stability on the inside. Service mesh microservices let you go fast experiment, use lots of different languages, platforms, technologies, and focus on flexibility for teams and availability of services, and then connect those APIs to the microservices. Now, the way I describe it, most people think about it, it should be like this, nice and orderly, everybody's heading the same direction. Reality often looks like this. It's a big change to teams, processes, technologies. It can be a mess. It's not a panacea. And Gartner says that more than 90% of organizations that try microservices will find they're too disruptive and kind of roll back and relax some of those constraints, like being able to share data sources and things. Now, can be a slippery slope. That's the subject of a different presentation on a different day. I've done webinars if you want to look them up. Okay, so that's setting the stage. Now, what's next? Well, for hardware, I think it disappears. You're not going to be talking about chips and processor speeds and things like that much in the future. It's what do I get out of it? What software does it enable? Things like self-driving cars from Waymo. One bit of hardware I think is interesting, and we're going to actually talk about for a while, is this quantum computer. This is a quantum computer from IBM. Looks pretty cool. Why quantum? Well, because for some problems, not every problem, quantum computers can do things that simply aren't feasible with classic computers. Right? If you look at on the left column, qubits, quantum bits in a quantum computer, very small number of those bits translates to a nearly unimaginable number of bits required in a traditional computer to get the same task done. And we've already got quantum computers in the world with on the order of 70 qubits. So getting powerful fast. Quantum supremacy could be here now, depending on your definition. But there are certain things it can definitely do that you can't do easily with a traditional computer. And to harness quantum computers, we're going to have new programming languages. IBM's got one. Microsoft, there's a bunch of them. And I love the fact that there's something called teleport operation. This example code. You can imagine it now, right? There's a QA department at some point that's going to say, well, hey, developer, this test failed. And the developer says, well, it worked in my universe, right? It's going to be hard to debug quantum corner cases. Let me say it that way. A lot of practical things also happening in quantum computing. Volkswagen, for example, working on citywide traffic management to handle all the cars in the city with pedestrians and everything going on, and try to seamlessly manage that and change traffic lights on demand, etc. We're going to see DNA-specific medicines, massive amounts of research and improvements with quantum. It's so important that Gartner says in 10 years, it's going to be a, quote, revolutionary technology. So what does that mean? Well, they've only named 3 other things revolutionary in the past: the Industrial Revolution, World War II, and the internet. So we're talking about game-changing, society-changing type level features and availability. And it's coming just around the corner, really. All right, what's next is software. That's hardware. Well, speed. I think Google kind of set the bar a while ago with instantaneous. I think in the future, instantaneous is not fast enough, as funny as that sounds. We're going to talk about what's beyond, proactive, not just reactive. Security, only one thing to say about that in this talk is you got to get it right. Nobody cares until you mess it up, and then they leave you to go to something else that looks more secure. So don't mess it up. All right, I think here's what the future might look like of computing. We're going to see this. You might say, well, this looks totally normal. What's different about this situation? Well, what you don't see, I think, is even more of the concepts of the OK Googles and the Siris and the Alexas, listening, watching, to always understand our context so they can be proactive and react immediately to requests. I think you're going to see, yes, phones and tablets and laptops, and also actuators for everything in the environment. Now, Dad can't even figure out the clicker, so he's hopeless. But I think here's what shopping might look like in the future. Okay, it's not that. Clippy must die. Maybe it's more like this. It's still not quite good enough because this is still reactive. I think it's going to look maybe more like this. I've got my phone here. You can see on the screen. I'm going to say, Sparky, I need some new shoes, because I named my personal digital assistant Sparky, term that might make a comeback. And Sparky's going to say, okay, what do you think about these? So why do I see these shoes in particular? Well, because I'm on a hike right now. I'm from Colorado. I'm in the mountains. I'm hiking. I've been complaining about my feet for the last 15 minutes. Sparky is listening, understanding context, right? He knows how much I typically spend on shoes, what styles are in fashion based on my social networking, what friends are wearing, what trends are happening, how much I like to spend based on past purchases. He's read the reviews on Amazon, read the reviews from expert footwear recommendation sites, and synthesized all that and presented it to me where I didn't have to say any of those things. It just happens. I'm going to say, okay, let me see the brown ones. And Sparky's going to immediately render those for me. Now, this is definitely not a picture my wife took with an iPhone in my bathroom. This is a render from the future I brought to you at great expense, right? Marking the shoes as if they've already been broken in for me, so I can see what they're going to look like on me before I buy them. I'm going to say, okay, great, those look good. I'll take those, Sparky. And he's going to say, good choice. They're confirmed to arrive in time for next week's hike, because he knows, again, my context, my calendar. There's another hike coming up. I'm going to want them in time for that hike. And he took the liberty to go ahead and order some socks, where he did all the research, read the reviews, figured out what I want to spend based on past purchases. Again, all about me and my context, automatically brought to bear without me saying any of this stuff. And he put the charge on my Apple account, so I'm getting more iStuff points for an iVacation, because he knows that I'm an Apple fanboy. So again, all about me. It's about, as a user, I want to achieve my goal quickly and get on with my life. I want the computers to react to me before I have to ask for it. I think that's what software of the future is going to be like. Think about implementing APIs and exposing your service to let it be discoverable by others, and the AIs will connect them, and you'll get usage of your APIs. I think that's going to be a lot of the future. So again, all AI driven. We talk about software eating the world. AI is going to eat software, meaning the companies that are next are going to harness AI and take away market share and put the companies out of business who don't go down this path quickly enough, just like with the traditional companies. It's all about accelerating pace of change, machines replacing human labor, overall prosperity, all driven by AI. So much so that a lot of the analysts are saying immediately go hire grad students in with an AI specialty. You may not know what to do with them today, but by the time you get them, you will, because they're hard to get. They cost a fortune. There's not enough of them to go around. So get your fair share. I think we're going to see a lot of AI in development, a lot of bots performing actions and builds and doing deployments for us, and code reviews, and looking at documentation, enforcing guidelines, automatically testing in a lot of cases are UIs. Things like open source Storybook in the React world, making it easy to visualize and review. Things like Perfecto and Testcraft, using AI to automatically maybe make sure tests aren't fragile and are more resilient to change. Right, so AI to help testing. I think we're going to get better results. We're going to have the AIs mentor junior developers to bring them along, show them best practices, sort of feed them stories so they can start with something easy and scale up to more challenging problems. It's going to be all in the tools developers already use, so it can plug in seamlessly. They don't have to learn new things or jump out of where they like to be. And it'll be easier to keep up and harder to ignore changes. One good example, Apollo GraphQL plugin for VS Code. I think this is a great kind of case study in what's going to happen in the future. We can see that right in the IDE, as you're writing a query, the AI is going to pull together data and stick a comment in the code that you just wrote that says, at the 95th percentile in production, if you add this field to your query, it's going to cost you 44 milliseconds of performance. So before you ever deploy, before you even check in the code or finish writing your query, you already know the impact. That's a good example of how AI is going to synthesize, bring us information, and put it just where we need it, when we want it, how we want it, to kind of make us all superstar developers. More AI, for example, synthesizing. We've got lots of voice recognition today. We've also got AIs doing better lip reading than the best human lip readers in the world, and by a large margin. So we're going to see those combined. Listen to the voice and read lips to get nearly perfect results. We're seeing AIs that are already way better than the best Texas No Limit Hold'em poker players in the world, and it's not even close anymore. Even when the humans gang up as a team, they still can't win. We're seeing things like generation. Like, none of these faces are real. These are all AI generated, and the algorithms are much better now than when I took these examples. So much so, in fact, that as of this year, the counterfeit reality, including written content, video, images, all going to be so well faked that even other AIs won't be able to detect it. Now, it's an ongoing battle we'll have with AIs, but generally not good for us. It's going to be tough to, maybe blockchain will help. That's another talk. Deep learning, deep reinforcement learning, things you've probably heard about. AlphaGo, playing Go better than the best human players in the world. Just 10 years ago, most AI experts said it would be 100 or 1,000 years, or maybe never, that a machine would beat the best humans. Now it's already been done. AlphaGo worked by studying millions of games, learning from humans. AlphaGo Zero was only taught the rules of the game so it wouldn't learn any bad habits from humans and plays even better. And they said, well, if we can teach the rules of the game and have the computer play itself, let's teach it chess and shogi, Japanese chess, and see how that works. 9 hours of training later, among the best in the world. So very fast. And the newer version of this, they don't even bother to teach it rules of the game. They just have it observe or randomly make a move and are told simply whether the move was legal or not. And that's all it takes to learn the game and become the best. So DeepMind, a part of Google, doing a lot of these things, has a kind of a motto: solve intelligence, use it to make the world a better place. I just don't know if they mean for us or for the future AI overlords. I guess we'll see. Now, what about AI and open source? Well, it turns out there's a lot of open source. In fact, almost 9,000 different open source packages and communities involved. So really no excuse not to start incorporating some AI and being more proactive, improving user interface in whatever you're building. It's so powerful, in fact, that we're seeing that in 10 years, possibly $16 trillion net improvement in global economy from AI. Right? It's going to raise all the boats. Unfortunately, it's going to be a little bit shaky getting there. A lot of jobs lost as we transition from the old economy to the new one of bits and AI. Doesn't sound great, and I'd say try not to panic. Even though the godfather of AI said that in 3 to 8 years we'll have the machine with the general intelligence of an average human being, he said that in 1970. So his estimates of story points are probably about as good as the rest of us. Right? So maybe we've got a little while longer. We're also going to fight back. I think Humanity 2.0 is coming. We're going to augment ourselves. This is something from CTRL Labs, little wireless thing you can wear around your wrist that intercepts signals from your brain down to your hand, where you can control things in a virtual world and even learn to not have to move your hand, to simply think and make changes. Elon Musk has also got a company, Neuralink, talking about embedding this neural lace on the right, something like this, in your skull to wrap around your brain so you can simply think to get information from the internet and act with the outside world. It's going to take something like that to keep up with the AIs in the future. All right, so how do we get there from here? That's a lot of big picture stuff. You might think it's pie in the sky. Let's bring it back to ground a little bit. Pull in. I think you're going to see things like GraphQL, progressive web apps, AI foundations of software, bots, chatbots. This is the next step on the way to a lot of those things we talked about. These are the building blocks going forward. Now, engineers can't know everything. We talked about lots. Full stack is all the rage. Performance, security, scalability, UI, UX, and now comes AI and quantum computing. How can anybody keep up with all that stuff? And yet, you have to know a little bit about all these things. Everybody wants breadth. And then pick one thing to be extra deep at, to stand out from the crowd. So I think the action plan for developers to maximize your value in that future world we talked about, focus on the things that are rare and extra valuable: user experience and AI. And to get there, progressive web apps, single page apps, offline first, right? You've got to be fast. We talked about instantaneous and proactive. Things like GraphQL to speed your time to market and get the data the way you want it, more declarative again, and start using AI to improve your user experiences. Invest in your future. Train the new tools. They're coming quickly. They're out there. Don't reinvent. Use open source. Use the commercial tools. Use services. Use SaaS. You've got to go faster than ever before. And if you're in a big company that feels slow and heavy and can't keep up, act like a smaller one inside of it. Carve out smaller teams. Try to be flexible. Maybe think of microservices like concepts, independently moving parts, so you're not stuck in the quagmire of the overall company. You've got great smartphones and watches and things at home as consumers. Try not to skimp on user experience just because you're doing enterprise apps at work. Try to give the best user experience everywhere. So conclusions, a lot of change in time pressure. I talked about hundreds of millions of new apps in a short amount of time. A massive amount of new developers, not enough developers to go around, right? So you're pulling in the people who are now being forced to be developers who maybe weren't. Lots of new tech, and you're doing it 10 times faster than ever before. So, what could possibly go wrong, right? I think something like this is probably more the actual picture. Software is getting bigger, more lines of code, more apps, more APIs, more open source. Use tools, use frameworks, things that can keep up with the scale, help you not reinvent wheels when you face these challenges. On the bright side, we might see universal basic income. There's lots of experiments with COVID. That's happening now in places. Things are getting cheaper. We're going to be able to live anywhere with our personalized healthcare, thanks to quantum computing and others. Maybe life will be like this. We'll have more time to explore. Maybe it'll be like this, more time for recreation and fun. But whatever it is, it's all powered by software. Think bits, user experience, and AI. I'll leave you with the final quote. The future's not yet been written. There's no fate for what we make, but what we make for ourselves. So build a great future with a great user experience.